Hello, my name is Seung-Woon Park and Digital System TA. So let's begin. First, before we start the lab, so notice part and next step is exam brand code. First, you look the project navigator and default set is hierarchy. So first step is click the file tabs and right click your current project, like this is your current project, and menu Control plus S to save. So when you save, it's edit this list and right click and choose the set as top level entity. So it is necessary to run the code. First, example and code by 10 page. It means in presentation, your lecture note in 10 slide. Yes, here we go. A or B and A or C and D. It equals A or B and C and D. So let's look at this code. A or B or A or C and D. But this code means not equal this function. So you change this or to and. So you can get this function. And when you learn this code in simulation waveform editor, so this is input part, it doesn't matter. This output part is the method. So this form to this function. Next, x or y prime, x prime, y prime, and x and y prime equals x prime or y prime. The explanation is the Morgan's. So type this function equals not A or Y prime. This code means this function. So you can get this form. It means 0, 0, 0, 1, 1, 0, 1, 1. So 1, 0, 0, 0. So let me explain the truth table. X, Y, F, 0, 0, 0, 1, 1, 0, 1, 1. When x is 0, y is 0. Function equals function is 1. Next, x is 0, y equal 1. The function equal 0. Next, x equal 1, y equals 0. Function equal 0. X equal 1, y equal 1. Function equal 0. So, in this function means like this. 0 or 0 inverse means 1. 0 or 1 inverse is 0. 1 or 0 inverse is 1. 1 or 1 inverse is 0. That's it. So now, 12th page. X prime and so see this code, line 19. Not x and y and g, or not x and y and not z, or x and g. So this is same, right? Now let me check. This upper side is the input value, so it doesn't matter. This downside, lower side is output value. It matters. So this form 0, 0, 1, 1, 0, 1, 0, 1. So this is the end of this form. Okay. We see this function and this function. Now we comment it. So when you type this function, you can get another form. So try. This is when you want multi-output. So this is the many way to, but this way you can define the first input, first 2 input, 1 output, second 2 input, 1 output, third 2 input, 1 output, fourth 2 input, 1 output, fifth 2 input, 1 output, sixth 2 input, 1 output. So this is so hard to explain it, so hard to see it. So I'm not recommended this way, but this slide in 17th page, same input port, so I mean node, 2 output node. This is the what I recommended way. So function 1, function 2. Function 1 means x and y, or not x and z, or y and z. It means function 1. Function 2, x and y, or not x and z. So this slide is the function 1 equals function 2. You can type this code, but when you try to show the simulation waveform editor, when you run this code, you can get this output. It looks same. So function 1 and function 2 is same output. Function 2 is lower cost. Literal cost is 6 literal cost. Function 2, 4 literal cost. So 4 is more efficiency. Function 1, function 1 and function and not function 1, so inverse function 1. Function 2, function 2 inverse. This is the sum of product and product of sum. So function 1, when you function 1 inverse, and inverse means function 1. So you can see that function 1, no. You can see this waveform. Function 1 inverse, you can see the inverted each other form. Function 2 inverse seem like inverted form. You can see. So when you want to try this, you can type this code and sum of product and product of sum, like this. When you want to show the circuit, so if you put the buffer on the circuit, you can see the circuit configuration. When you click the tools tab and select the netlist viewers and select the RTL viewers, and you can see this picture. This is the function not y or not c and y and not g, or x and y. So this means this picture, this logic circuit. Same thing. It's 29th page. This commented code, I want to both function 1 and function 2 to explain this circuit picture, but it cannot be. So, but I can, but need to more code. It means component with edit, but it's too hard. To beginner. So I recommend you like this, commented or uncommented, so you can get this result like this. You can compare the lecture note. So this problem is that same function, so you can get this, it doesn't matter, input node, this output node is the matter. Function 1 is A and B, or C and D or E is function 1. Function 2 is A and B, or C and D, or C and E is function 2. So both function is equal. So look at this waveform. Function 1 and function 2 is the same. So you can see this waveform easy to see. Next, 30 page. Function equal x. So x and not y or z, and x or y or not z. I mean, this is not correct. Not z is the correct. So this function is correct. So you can learn to the tools, netlist, view, RTL, RTL view, and you can see this figure. So you can compare the paper. Example code, page 40. Now we can explain with K-map. It means column map. So let's count the literal cost. Function 1, function 2, literal cost is 16. Now, function 2's literal cost is only 2, but function 1 equal is that function 1 equal function 2. So we can show this function 1 output node, function 2 output node, input node, doesn't matter. So you can see these forms. Function 1 and function 2 is same, but function 1 has 16 cost, function 2 has 2 cost, but output is same. So function 2 is more efficient. Now we can explain to column map. Explain with column map. So not W, not X, not Y, not Z means this part. W, not X, not Y, not Z means this part. Not W, not X, Y, and Z, not Z means this part. W, not X, Y, not Z means this part. But column map can edge to edge it seems like this. You can see this shape on the paper. So we can make the square like this, each corner. So this part is not G, and this part is not X. This means not X and not Z. So we can see this output nodes and result is safe. With result is same. I'm sorry. Example and code number page 41. Function not A or A and B. Not A or A and B. Wait a minute. So you can like this truth table. You can see this truth table 0 0 0 1 1 0 1 1 and function. So you must see this part. A, B, and function F. This means 0, and this means 0. This means 1, 1, 0, 1, 0, 1. It's similar with truth table. So it can show you function is 1, 1, 0, 1. So 1, 1, 1, 0, 1. I can explain it, not A or A and B. So use this case. Not A and B. Logic AND is all the element is 1 and equals 1, but B is not 1, so it can be 0 or 1, not 1, not A means not 1 in this case. So 0, 0 or 0 equals 0. So any other cases is 1, 1, 1. Let me show this case. So not A or A and B. So logic AND must be 2 both 1, get 2 both 1 equals 1, but A is not 1, so it can be 0. And not A means not 0 is 1, so 1 or 0 means equals 1. So that's it. Okay. So now explain this function. Truth table. And 0, 0, 0, 1, 1, 0, 1, 1. And this is function. But this function actually have C, but it doesn't matter. It don't care. Whatever C is 1 or 0, I don't care. So I can build this truth table like this, but you can see waveform simulation. This C exists, but it doesn't matter. The function don't have C. So 0, 0, 1, 1, 0, 1, 0, 1, and 1, 1, 1, 0. So you can write this truth table 1, 0, 1, 1, 1, 0. So let me show you. Not A or not B. So we can see this case and this case, so we can get this. So first, this case, and second, this case. Case 1, not A or not B. Not 0 means equals 1. Not 0 equals 1. 1 or 1 equals 1. That's easy. But not A or not B. Not 1 equals 0. Not 1 equals 0. So or 0 or 0 equals 0. Okay? Let me explain another one. Case number 3. Not A or not B. Not 0 means 1, or not 1 means or. So 1 or 0 equals 1. Okay, let's go to the next slide. Now you can see the column map, and you can see not C and not B. This part, not A, so not A, not B, and not B. So you can see this B, not B part, and not A part. And this waveform get this shape. So you can see the one got a six of 1, 1, 2, 3, 4, 5, 6. Okay. So you count this. How many 1 in this form? Oh, first, you must know the minterm. A, B, C, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So this is the minterm. Can mean 0 to mean 7. And mean 0 to mean 7. Mean 7. So minterm part like this. So you can see this number on square. This means minterm number. Minterm 0, when the minterm 0, 1, 0 is 1, so like this. One, 2, 3, 4, 5, 6, 7. So you can see the minterm 6 and minterm 7 is 0. So there is nothing in the 1. But minterm 1, 2, 5, it have a 1. So you can check your code is right. You can check your code is right. Oh, notice is that this side doesn't matter. Okay. Now function G. A and not B, or not C. So you can see this kernel map, and how many ones in this K map? Let's count it. 1, 2, 3, 4, 5. It takes 5 ones. So look at this output form. It means minterm 0 to 7. And which minterm get the 1? 0, minterm 0, minterm 2, minterm 4, 5, 6. Let's check this out. Minterm 0, minterm 2, minterm 4, 5, 6. So your code show you like this, and paper show you like this. So both is equal, same. So this code means this K map. Let's check the optimization problems. So function h and optimization function h. A means HO. So you can check this formula like this. This means 4 square in K map, and this means 3 square in K map. You understand? So now this is important part. Optimization is when you H and HO got same output, but HO got a low cost, it means optimization is successfully. So this is called A and not B, or A and not C, or not A and C, or not B and C. It means 4 square. Not A and C, or A and not B, or A and not C. It means 3 square. So let's check this out. I can show you with color which square is the which function. A not B means A not B. This square. A not C. A not C. This square. Not A, C. Not A and C. Not A and C. This function. And not B and C. This not B and C. This square. So I can explain it. Minterm 1 to 3. Oh, no. Minterm 4 to 5. Blue is minterm 4 to 6. Black is minterm 1 to 3. And green is minterm 1 to 5. So, I must explain essential prime implicant. Which is the implicant? Which is the essential prime implicant? This and this. So this implicant and this implicant is essential prime implicant because this one and this one only have explain again. Minterm 1 to 3 have only one element of this one. So when you remove this square, it doesn't, anybody can hold this. So this is necessary. Same thing. This is necessary too. But this square and this square, square number 1, square number 2, one of these can be removed. It doesn't matter. 1 or 2 can be removed for optimization. So this function remove green implicant. So not AC, not A and C. Oh. So HO got A, not B. A, not C. Not A, C. But look at this. Output is same. So optimization is successful. Now we can get 50-page function equal not C or not A and not B or not B and not D. Code is right here. And let me show this. Yes. Not C, I can show you like this pen. Not C means this area, this square, and not A, not and not D. Not A and not D means this square. You understand? And not B and not D means here. So you can count the 1 in square, but it's too many times. So you can count 0, 0, 0, 0, the rest of them. So in this simulation waveform editor, at 0, 1, 2, 3, 4, 5, it means midterm. 13, 14, 15. So how many 0 expressed and which number is it? 0 appear 1, 2, 3, 4, 5, and 0 appear 1, 2, 3, 4, 5. So 0, 5 zeros. Chronomap got 5 zeros. And which midterm is midterm 3, midterm 7, midterm 11, midterm 14, 15. Midterm 3, midterm 7, midterm 11, midterm 14, midterm 15. So this is correct. My code equal paper chronomap. So let's go another optimization. Not A and not C and not D, or not A and D, or not B and C, or C and D, or A and not B and not D. Wow. Literal cost. It's too many literal cost. 12 literal cost. So let me check the optimization function. Not B and not D, or not A, not C, or C and D. Literal cost. It's just 6 literal cost. Is it same? You can run this code and you can get this result. This doesn't matter. It's input bus. This output node show you same result. So optimization is success, and it can 6 literal cost efficient. Is the same calculation. Okay, simple calculation. Next, now we can see chronomap G and chronomap GO, G optimization. So this means 5 square and G optimization means 3 square. So when you count the squares, stop this lecture and check this out. 5 squares. Also 3 square. Now, not B and not D, or not A and not C, or C and D. So check. C and D is here. this, not A and not C, is not A, not C, is here. Not B and not D is here. Because not B like this and not D like this. So it got a same result, so optimization is success. Now next page. Now we can see the function f and f optimization. It means 3 square. It means 2 square. So you can see this output. Same result with low cost. Now you can see this K-map. Not A and D means this. B and not D. This square. Last, not A and B. This square. But you know, this square is in the other implicant, so it doesn't necessary. It means you can optimization. So not A and D is survived. B and not D is survived. But not A and B, it doesn't survive. It can be removed. But result is the same. So optimization is successful. Next slide. Your question is, what is this? I can explain. A and C and D, or A and B and D. You can choose 2 of them. So you can see this Kano map A, Kano map B. So I could explain line by line. This first line means this. Second line, third line, fourth line means this. And last line, I choose A and C and B. So this square is necessary. When this square is disappear, I can choose this square is disappear, just in case. This element no one got this element, but so this is wrong answer. So this square is most necessary. And this is mostly this function and this either. This 3 square, not this, 3 square is must be necessary. I mean prime implicant. But this square and this square one is not need this function. So this square is A, B, D. It's rather square. So remove all of this, and this is red square. And A, C, D is blue square. So you can choose this red square or blue square, but I choose the blue square. So whatever you want. Page 57. Function equal not A and not C, and A and B, D, or A and not B and C, or not A and not B and not D. So this is 4 square, but you can confuse this grayscale. Gray is correct. Black is incorrect. You understand? Black square like this, like this, like this. Black square is not necessary to remember. This function means grayscale. So this square, oh, it doesn't observable. Grayscale is this, and this, finally this. So you can get the how many one is in this K-map. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 ones. So you can check this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Doesn't matter. And this K-map doesn't appear midterm number, but you can get this page 0, 1, 0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, 10. So okay. 0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, 10, 12, 30, 50, 40. So you can get the midterm is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So check this out. Midterm 0, 1, 2, 4, 5, 10, 11, 30, 15. 0, 0, 1, 2, 4, 5, 10, 11, 30, 14, 30, 13, 15. Yes. So there is correct. Your code and paper came up is correct. You can check this. Now next 58 page. You can see the function in burst. Why function in burst disappear? So you can see this. The 1 is hard to combine square, but 0 is easy to combine square. So function in burst, it means 0 combined. So like this, like this. Now A and B means this square. So like this. And C and D like this square. And B, not D, is this square. So when you inverse this function inverse to another inverse means function. So this formula of product of sum is like this. This is sum of product like this. So you can compare this formula, this function and this function. I explain this code. This is function inverse. This is original function. So you can compare this like original function and function inverse. So look at this. Perfectly inverse. So this is right code. You can build correct. You type the code is correct. Your code and paper corner map is same. Next, page 60. Function 1 and function 2. You can explain code like this, function 1 and function 2. And this time, we can thinking about don't care issue. Don't care means whatever you want, be it 0 or 1, I don't care. So this X means can be 1 or 0. So when you want to make bigger implicant, you can get this don't care. It can be like this. but bigger scale is more efficient. So get a don't care. Red scale is bigger than blue scale. So red is more efficient than blue. So it was. Now, this is the F1 kind of map. This is F2 kind of map. Now, I can explain like this waveform editor. Let's check function 1. Function 1 shaped like this. Like this. Let's get how many 1 in the function 1's column map. 1, 2, 3, 4, 5, 6, 7. Let's check this out. 1, 2, 3, 4, 5. But we can use was used don't care to 1. So counted them. 6, 7. We was use this 1. So let me check function 2. It used only 1 don't care. You got that? Yes. Let's check this. Count 1. 1, 2, 3, 4, 5, 6. So we counting 1, 2, 3, 4, 5, 6. Yes, there is correct. Now you can more check with min term. 0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, 10, 12, 13, 15, 14. And check the min term. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So let me check. 0, 1, 2, 3, 7, 11, 15. That's correct. So let me check function 2. 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 11, 12, 13, 14, 15. So let me check this. 0, 1, 2, 3, 5, 7, 11, 15. There is also correct. So your code and paper column is same. Now next, function inverse equal not D and A and not or and not C. So let's check. I mean, when the function inverse shaped like product of sum, it means I'll count 0. So let's begin to show you like this kind of not D is D square. A and not C is D square. So this don't kill become a 1. And when I painted this square is function inverse. So you can another inverse means original function. It original function is D and not A or C. So let me check this. Compare function inverse and function. So let me show you. This doesn't matter. Alpha function inverse. Perfectly inversed. So perfectly inverse. So remain this square is correct answer. So your code and paper column map is same. Now this is the last slide. When you get the first lecture of installation and execute demo, so you can easy to follow this lecture. So when you have a question, you can emailing this email. So thank you.